Lesson 4-5, solving two-step equations. So we have been solving one-step equations where you would either add or subtract, and then another set of one-step equations where you multiplied or divided. Now we're going to combine those and solve two-step equations. So I've kind of got steps listed to help you figure out where to begin. So the problems will look similar to this down here. You will have one term that has a variable to begin with, a plain number, a constant term with it usually, and then equaling another constant term on the other side. That'll be the typical problems that we start with. They definitely will get a lot more complicated than that. So I don't know if we can get rid of that press escape. Let me just try something here. Okay, let me go back. All right, so here's what you're going to do. Why is that on there? You're going to look at the side that has the variable. Okay, you're going to look at the side that has the variable, and that you go to that side. On the side where there is a variable, you go to the constant term that's with it, the number by itself. You're going to add or subtract that constant term to both sides. Remember, it's the opposite of what you see because you want the constant term to go away. Then all you should have left on the side is the variable term. Well, then you will multiply or divide, just like we did when that was a one-step equation, to get the variable alone. So your idea is to look for the variable first. Find if there's a constant term on that side, get rid of it, add or subtract that to get rid of it, and then do what you need to do to get the variable by itself, whether that would be multiplied or divide. Now, I will tell you they'll be getting more complicated. You might have some where there's more than two terms on this side. If that happens, you would need to combine like terms first. So let's just start with these and see what happens. Yeah, see, I've got one right here to begin with. But let's start with here. 50 plus 15x equals 485. So here's what we're going to do. The left-hand side has the variable. What's the constant term on the left-hand side of the equation, Tori? 50. How would I make the 50 go away? Would I add 50 or subtract 50? Tori? What? Yeah, so here's what I want you guys to do. This is really important to show all your steps so you kind of keep things organized. You're going to subtract 50 under 50, and then you're going to subtract 50 under the 485 and draw your line. So whatever you do on the left side of the equal sign, you got to do on the right. So the 50 minus 50 goes away. Bring down the 15x. Bring down your equal sign or you'll get lost. And then Tori, what's 485 minus 50? 435. And you should recognize this as the last set of homework that we did, the one-step equation. Tori, how do I get rid of that 15 with the x? Right, you divide both sides by 15. So this 15 divided by 15 cancels out, and x equals, well, off to the side, you probably need to do 435 divided by 15. 15 times 3 is 45, so 3 is too much. I would go with 2. And then 15 into 135, I'm thinking that is 9. Yeah, okay. So x equals 29. Questions about that? So let's go down to this one. We have a over 7 minus 12 equals 9. So I look for my variable. It's an a, and again, it's on the left. It doesn't have to be on the left, but kind of a lot of them will be. What's the constant term by itself on the left? Anybody see it? Stephen?
Would that be the 12?
The 12. And it says minus 12. So, Stephen, would I add 12 or subtract 12?
Add?
Yeah, so you're going to add 12 under the 12 and under the 9. So I got to bring down A over 7. The 12s cancel, and it equals 21. And Stephen, how do I get rid of that 7 now? It's A over 7.
Times that by 7.
Yeah, you multiply both sides by 7. These two cancel out. And A equals 21 times 7. 147. Oops, I put 142. That's wrong. 147.
This is not as hard as I thought it would be.
Yeah, it's not as bad as you think. You just got to follow those steps. You look for the variable, go to the constant term, get rid of it first. You're going to add or subtract, and then get the variable alone. Now, you will, anybody else writing the red still? Because I want to move down a little bit to give me some room for that problem. Okay. So let's look at this one over here. Just a little bit more to it. Negative 2x plus 4 minus 6x minus 5. Okay, so what I need to maybe make a little note off to the side, you always combine like terms on each side first. So combine like terms on each side first. And generally, you should go like terms on the left and then like terms on the right. If you can find any like terms on the left, you should put those together. Those you don't do opposite signs when you're doing that. You just combine them. And then if there's any on the right. On this one, I think you see that there's just some on the left. And Haley, what can you name some like terms on the left?
Negative 2, negative 6.
Yeah, negative 2x and negative 6x. So I'm in the whole 2, and I go back 6 more. Where would I be, Haley?
Negative 8, 6x.
Negative 8x. And then do you see any other like terms?
4 and 5.
Yeah, so I have 4, and I go back 5. So where would I be?
Negative 1.
Negative 1 equals 39. And now I'm ready to go. I've got all the like terms together on the left and all the like terms, there weren't any on the right really, and now I'm ready to go. So I look at the side with the variable, which is the left. What's the constant term by itself on the left?
1.
Okay, and it's a minus in front of it, so to make it go away, would I add 1 or subtract 1?
Add.
Yep, so you add 1 here and you add 1 here.
40.
And that's a 40. So negative 8x, the ones are gone, equals 40. How do I get x alone?
Minus
Huh?
negative 8.
It's negative 8x, which is times. So we're going to,
Add.
no, times. We're going to undo times. What's the opposite of times?
Divide.
Divide both sides by negative 8. So x equals, okay, now one's positive, one's negative, so the sign on the answer is going to be
Negative
negative, and 40 divided by 8,
5.
yeah, negative 5, good. X equals negative 5. So, yeah, there's a few more steps with that, but it's not impossible. I think you guys will do well. Let me, does anybody have any questions or writing any more of that? Let me see if there is anything else down here. There might be a couple more examples. I think there's one more. Okay, there is. This is the exception to the steps we had up there. Notice how this whole side is a division problem. Do you see that? That's a little different than just having this. This, and this are two different things. Do you see how over here, the negative 6 plus a, the whole thing's divided by 10, but over here, just the a is divided by 10. This one over here on the right, you'd follow the steps that we just did. But what we're doing here is a little different. Notice the note that I've got there. Multiply first if a constant is on the bottom of a fraction. We got to get rid of that 10 before you can move forward. And on one like this, you got to take this whole side times 10, and then you've got to also take the right times 10. And remember, when you do that, it's 10 over 1 that you're multiplying. That's why those 10s cancel out. And then you come back and you've got a negative 6 plus a, much simpler problem, equals 70. And then I only have one more step to get this solved. I have to get rid of that negative 6, so add 6 to both sides. And a equals 76. So this is the only exception to what those steps were above. If you've got the whole side as a division, get rid of that bottom, the denominator first, because that will mess you up if you don't. Okay, questions?